Welcome to Train Signal. I'm Ross Bagurtis, and in this video I want to give you a really solid introduction to router basics. Alright, so let's take a look at what a router does. So when we have two PCs that want to talk to one another and send messages between each other, we can do this by just connecting the two PCs together with a crossover cable. Crossover cable is an Ethernet cable that allows you to connect two like devices together, and we'll learn about that more in the video of Ethernet and switching. For the time being, know that these two devices are connected together and they have proper setup at the physical layer with the wire and proper setup at the data link layer with Ethernet. At the network layer now, we've assigned IP addresses to each of the devices. So the device on the left has the IP address 192.168.10.10. The one on the right is 192.168.10.20. Now, because the IP addresses are both on the same network, we know they're on the same network because the network portion of the address is the first three octets, right? The first three numbers in the address is the network portion. How do I know this? Because the subnet mask, which is written right below it, shows that the first three numbers here, 255, 255, 255, represent the network portion of the address. Remember, if we convert 255 to binary, it's going to result in 8 ones. So we have 24 sequential ones here that represent the network portion of our address. So because the network portion of the address on the device on the left has the same network portion as the device on the right, 192.168.10, we can pass messages back and forth between these two devices without any other equipment required. In the second example, if I change the address of the workstation on the right to 172.16.10.20, now I am unable to send messages between these two devices because the network portions of the address are different. This is one of the most fundamental basic rules about how traffic can be passed between devices at the network layer. Remember, network layer of the OSI model is the portion of the OSI model that deals with IP addressing and routing. So we're working with internet protocol here to move messages back and forth. So what we've done is, in order to fix this problem of being able to have devices with different network portions talk to each other, is we introduce this router. And a router, what it is a router is nothing more than a fancy PC. And I say fancy PC because this router has all the general components of a PC. It has a processor, it has memory, it has storage space like a hard drive or a flash drive. It has network interface cards on them. As a matter of fact, a router has more than one network interface card on it. Almost all routers will have at least two network interface cards, if not more. The equipment that I got to work with when I was at the hospital as a network engineer, some of our routers there had hundreds of interfaces, and we had hundreds of those devices. So in data networking, the router can have lots and lots and lots of network interface cards. Either way, it's still behaving very similar to a PC. So what we do then with the router is we assign one of the network interface cards on the router to the network on the left side, and we assign the other interface an IP address that is on the same network as the device on the right side. So our network interface card on our router then is 172.16.10.1. And the IP address on our workstation is 172.16.10.20. This is perfect because the network portions match and the host portion does not match. Every single IP address in an IP network must be unique. So when I have this set up, on my right, I have two IP addresses on the same network. Same thing on the left. My router is assigned here 192.168.10.1. which has the same network portion as my PC on that side of the network. So now what I've done is I have a device on both sides of the network where both PCs can talk to the router. So both PCs have an IP address on the router they can communicate with. Well, we're going to take a deep dive and take a look at exactly how frames and packets are built in order to move across this network. But for the simplicity part of it, once I put this device in and give it IP addresses on each interface, the router now can actually move the packet from the device on the left to the device on the right without causing any problems. So we need this router in order to get traffic from one IP network to a different IP network. And that's pretty much its sole job. If we take a look at our home network, and this is a drawing that I've shown you before in Introduction to Networking, and this is a pretty simplistic drawing of your home network. I have a wireless computer here, a wired computer here, and then the wireless router, which connects to your cable modem or DSL modem. And if we look at the networking here, we'll find out that unless you have some unusual or obscure setup in your home network, what we're going to find out here is that the network portions of all three of these devices, the laptop, the wired PC, and the inside interface of our wireless router, the network portions on those addresses are all going to be identical. And I actually encourage you to go and log on to your wireless router if you're authorized to do such a thing and take a look at how your home router is set up. Look at the internal network and see what IP address is assigned to it. Look at the internet side of it, see what IP address is assigned to that. And you'll notice that the network portion on the inside of your network is going to be different than the network portion on the outside of your network here. So in my drawing here, 192.168.10 is the network portion of my address on the inside of my network. 203.0.113 is the network portion on the outside of my network. So what the router is doing here is the router is allowing my traffic on the inside to get routed out to the public internet so we can pass traffic across it.